All right, so we talk about cognition. Cognition is kind of like how you're thinking, how you're processing information, awareness, your perception, all that sort of thing. Knowledge, memory, it all sort of flows together to make what we call cognition. So 75% of our brains is association areas where that integration of sensory and motor information occurs. So that's kind of a big part of our brains. And that's why we're able to process language and understand emotions and have social cues and all this kind of stuff. All that's going on up there. So we've been talking about some of these brain lesions, depending on where they are, can affect different areas of your cognition. Your temporal lobe, agnosia, is an inability to recognize objects. So you wouldn't know, can't tell what a chair is or a desk or any number of things. Or prosopagnosia is a problem with recognizing faces. So then you wouldn't be able to see like, oh, that's my friend Steve or whatever. So in the frontal lobe, we talked about that, personality, as well as planning and executing appropriate behavior. So all those judgment kind of things. Anybody know Phineas Gage? Ever heard of this guy? Yeah, what did Phineas Gage do? What do you know about him? He's probably that, right? He's got a big spike in his skull, right?
Yeah, so, like a railroad worker.
He was a foreman on the railroad workers. So the railroad had hired a bunch of Irish guys to build the railroad, and Phineas Gage was their foreman. He was 25 years old, and he was in charge of all of them. And the way they would do it is they would, when they laid down, when they were blasting areas out, because they had to dynamite a lot through areas to be able to flatten out the ground. So they would drill a small hole in, pack it with gunpowder loose. They wouldn't tamp down the gunpowder, but they would put gunpowder in there. Then they would put sand and clay on top of it, and then they would pack that down. And then they would have a fuse in there that they would light and blow the charge to then, cause the explosion, blast the rock out of the way. So Phineas Gage, he was responsible for that demolition process. And so he had custom made a really giant iron rod that he had, and the end that he would hold closest to himself was sharp and pointy. I don't know why he decided that was a better idea, but the other side was flat. So when he would put it in, it wasn't there. It was, I think like an inch and a half wide or something. So he would put that in the ground. He would use that to tamp down that clay and sand mixture. So there was one day toward the end of the day, it was like 4:30, close to quitting time, and he had turned his head and he wasn't paying attention because some of the other guys were being loud and rowdy. He was trying to get them to calm down and finish their job for the day. So he turned his head and he looked back, and they're not really sure what had happened. He had an assistant who was helping him with the gunpowder. They're not sure if he thought that the clay and sand was already down there, or if something else happened. Whatever it was, the clay and sand had not been put down yet. It was just the gunpowder in there. So he went to pack it down, and the iron rod hit the rock and caused a spark, which then ignited the gunpowder and caused a blast, which then forced that metal rod. And he was probably talking at the time, so his mouth was a little bit open, forced the metal rod all the way through his skull. I think it was several feet long. It didn't get stuck like this. It went all the way through his skull and out the other side. So the whole thing passed through, and he got knocked out, not knocked out, he got knocked backwards. He never lost consciousness, so he claims, but he had a giant hole in his skull. And so then it's a small town that he was in, so he went to the country doctor, and there was two doctors that saw him. The first one looked at him and was like, "Are you sure you never got knocked out? Are you sure? Are you positive?" And he's talking to him just fine with a giant hole in his skull, But then when he got home, and after this accident, his family, there's kind of a lot of legends that go around, like the rod got stuck in his skull, or kind of all these different things. We don't really know a whole lot because nobody really studied him after the fact. So we know we can imply things afterwards about what people said. The doctor that followed his case most closely was the second country doctor, who actually probably saved his life because he went through and he left the hole, but he did remove some of that dead tissue and everything. Again, that tapioca pudding, right? But unfortunately, the guy was using his fingers from both sides of the head, so he was coming in, from the bottom and scraping stuff out of there to get bits of skull and debris and everything to clean it out. So then he developed a really bad fungal infection, probably from what was on the doctor's fingernails because he wasn't wearing gloves. And so then that almost killed him. But the doctor did, instead, like we're talking about King Henry, they did not tap his skull to release the pressure, but this doctor actually did put another hole in his skull to release that pressure because it was building up behind his nose. And so he did another hole, released the pressure, got the pus off, and probably saved his life from that one. So, but he didn't do a really good follow-up on like a neuroscientist would. where they would ask certain questions. So he just kind of asked particular things, and he would do some experiments with him. Like he offered him, Phineas Gage had found a bunch of pebbles in the stream bed that he liked. He thought they were nice looking, but they were just little rocks. And the doctor offered him $1,000 for the rocks, and he said, no, I'm not going to take it. So again, showing poor judgment, because who wouldn't take $1,000 for some rocks he found in a stream, right? So, but his family and friends noted that he had a personality change. They say he became irreverent, profane. He wasn't like this before. He was a really nice guy. Everybody liked him. He got home, and he's cursing up a storm, and he's kind of a jerk, and nobody really get it. They said he just wasn't Gage anymore. He wasn't the same guy. And so that's where we get a lot of the frontal lobe damage from. So neuroscientists believe that planning, moral judgment, emotional control, and functions are all part of that prefrontal cortex there. And so he couldn't process that the same as he could before. All right, so based on where that rod passed through his head, he said that he didn't lose consciousness. What do you think? Is that possible? You don't think it's possible? Okay, so where is the center of consciousness? Like, where's that? Where's the part that keeps you awake or puts you to sleep? You get knocked out.
It's further back.
It's further back, right?
Yeah.
So that reticular activating system is further back there behind his ear. That's kind of the trigger point for it. It does sort of spread out through there, but the primary point is down there behind that earlobe and around kind of, just above your jawline and everything. So it's very possible that he actually didn't ever lose consciousness.
But, like, can't you pass out from, like, too much pain?
You can, but he actually didn't have a lot of pain. So there's not a lot of pain receptors in the brain, right? The pain would be from the skull itself and the skull fracture. Your processing centers also can kind of override things. So we talked about those analgesic centers. Sometimes they just, to defend you, they sort of shut down and don't process the pain quite as much. So that's why people have like terrible things and they'll be like, oh, that doesn't hurt too bad. Your brain's like sort of protecting your body from that pain. And, again, he really, although he had a giant rod pass right through him, it did keep going. And he was, you can pass out from too much pain, but he
Did it say how long he lived?
He lived a normal life after. Normal as opposed to, he wasn't the same guy anymore, but he lived
10, 15, 20 years. Like
I think he was 25 at the time. I want to say he didn't die till he was in his 50s or 60s, okay. Something like that. So, wow. He worked as a sideshow guy because he didn't have the prefrontal cortex anymore, so he wouldn't make good decisions, so he wasn't a good foreman anymore, so nobody would hire him, but he got a job at a sideshow. That fungal infection actually caused him to lose his sight in his left eye too. So that was constantly closed from that point on. But he would go and stand in sideshows and at P.T. Barnum's circus. And then if you paid an extra dime, you could actually feel the soft spot in his head where the bones never grew back. So, get your money's worth when you go see Phineas Gage. It's only a dime. Touch a soft spot in the skull. All righty. Questions on the accidental lobotomy of Phineas Gage and where we have our judgment centers?
I think actually later regained some ability to.
Yeah, he might have a little bit.
He died in South America where he was a stagecoach driver apparently and was apparently really responsible.
Oh, I didn't read that part. That's cool. Yeah, so.
Generally, I remember reading that for psychology.
Okay.
It's a kind of a myth sort of thing.
Yeah, there's a lot of, like we said, he never wrote anything down about his experiences. He didn't keep logs. We didn't have a lot of people testing him, so we don't know very much about him and kind of what he was. But yeah, so I didn't realize he had gone down and that's happened a lot of times with people too. They've been able to rehab, and although their initial injury is pretty severe and their deficits are severe, they're able to kind of use other centers of their brain and sort of overcome some of those things. So people we'll talk a little bit about language here in a bit, but people who have trouble with who have damage to their centers that are focused on language, that's all on the left side of your brain. They're sometimes able to use the right side of their brain to sing, and that's how they can communicate, because singing uses a different brain center because it's the creative side on your right side than speech and language does. So Gifford, this congresswoman down in Arizona that was shot, Gabrielle Gifford, right? So she actually learned to communicate again by singing initially, and then retraining that area to then do that as speech. So, yeah. Memory. So information management requires learning, memory, and forgetting. Forgetting things is actually kind of a benefit. You don't want to forget everything, obviously, but if you have too much information in there and you can't forget anything, then it becomes another problem. There's a guy in Russia who had a problem with his memory system that he remembered everything. He was a reporter, which makes sense, right? And so he would, they would tell his editor got upset with him one day because he wasn't taking any notes. And his editor was like, "Why aren't you taking notes? What's wrong with you? Why aren't you listening? Tell me what I just said." And he repeated verbatim like the whole conversation that they'd had up to that point. Told him every little word, and he thought that was normal for everybody, that everybody could just be able to remember whatever was said. The problem was he couldn't ever forget anything, so everything was continually stayed in his head, and it became overwhelming for him. So he didn't hold down a job as a reporter very long. It kind of lost a lot of it because it was just too hard to keep everything in track. He would use kind of memory tricks like they teach you today about, but he would sort of like picture his walk home that he knew, like from the office to home. This is what I walk by every day. And when he's trying to remember lists of names or numbers that he could do, like he could remember, hundreds of numbers all in a row, or even out of row, just like a list of any series of random words. He could remember it because he would take images from his walk home and he would visually put the words in all those places. And so then he would just retrace his steps going on his walk home and remember, I passed this fence and that's associated with, stand or whatever word that it was that they had given him. And so he would remember the entire list, and it would be, huge, long words. So, but he couldn't, comprehend everything because it was too much. All that, like if he would read something, he would remember everything, and then he couldn't get the big picture of the comprehension, what the passage was trying to say. He would get so stuck in the individual words of the passage that he couldn't, get all the picture in there. So, and then anterograde amnesia, they can't store new data. That's what we're talking about for the folks that couldn't remember new things. Whereas retrograde is they can't remember the old data. And then hippocampus is important in organizing sensory and cognitive information into a memory. So your hippocampus, as you take in information, that's how it kind of gets looped into becoming a memory. And there it sits. So any lesion causes the inability to form new memories. So those are the folks that, again, they'll have that. There was one guy even who, you see, he was a retrograde one. He might be still alive. What is his name? Weaver. Clive Weaver. He's a conductor or a musician. And so he had an injury that he can't remember. So he's a retrograde amnesia. He couldn't remember old data. And he still can't make new memories. So he would, he basically he always has a sense of awakening. Like, I was never awake before. Now I'm really awake. Oh, it's 8:48. I am awake now. It's 8:49. I am truly awake right now. Like every minute he was, feeling like this is the first time I've ever been conscious. I've never existed before this very moment. And you could show him videos of himself before, and he's like, that's, you're lying. That's not true. I was not awake then. I was not conscious. Now I'm truly awake. So he can't, he's improved over time. Again, his brain is sort of doing a little bit better. But he, being a musician, he can play a full, because it's a different kind of memory, he can play a whole piano piece and just play it beautifully without any problems. And no matter how long it is, it can keep going. But then when he's done with it, it's exhausting for him. He fully shuts down, and it's overwhelming because now he has, again, he's lost everything, and I'm awake now for the first time, even though I just played this beautiful piano piece. So, Clive Weaver, I'm pretty sure his name is. You can Google him. So, hippocampus, so, and then again, the cerebellum helps learn those motor skills. So we have different parts of our memory. Again, that's why he can play the piano without losing his place on the piece and musically, but he can't, store a new memory or realize that old stuff had ever happened before. And then the amygdala is important in that emotional memory. So memories typically have an emotion associated with them or several emotions associated with them. You saw that Inside Out movie, the little girl had the sad emotion, the happy ones, and the core memories and all that stuff. So that's your amygdala there, and that's storing your emotional memory. All right, thoughts, questions on memory, issues, concerns? All right, so prefrontal cortex, again, that's your emotions, how they're expressed, your seat of judgment. And they form kind of in the hypothalamus and the amygdala. And that's so artificial stimulation of that area produces fear or anger, pleasure, parental affection, etc. So you can stimulate, you put electrodes in there and give little shocks to those areas. You can make people feel these things. So there you go. Median forebrain bundle or a rat or a human foot pedal. Press it all day to the exclusion of food. report a quiet, relaxed feeling. So, they stimulate those areas, and even though they're not, so then they get this relaxed feeling just because that electrode's going off in the right spot. So much of our behavior is learned by rewards, punishment, responses of others to them. It's a lot of it. Again, this is a really, really cursory, just basic thing. And a lot of it we still don't understand because there still is, kind of a self, and there's a little bit more to our brains than just what we know. And there's a lot of things that people are still trying to figure out. So a lot of times this is an oversimplification. So, just kind of giving you guys an idea. Again, here we go. Here's your lateral fissure down the middle here, your central sulcus, and your precentral gyrus in the frontal lobe here, and your postcentral gyrus in the parietal lobe. So your somesthetic signals travel up. Oh, those are big words, right? So they go up your spinal cord. All right, and that's all your touch, pressure, stretch, hot, cold, pain, and then your postcentral gyrus is the one that kind of processes all those things. So all those sensations come up your spinal cord through those fancy words, tracts, and into your postcentral gyrus. So I don't know if you want to say postcentral pain and associate that with all those sensations. Maybe that'll help. This is what's called a sensory homunculus. This is what it would look like if if the different areas of your brain, how much brain area was directly related to the different areas of your body. So you can see your face here has actually a lot of sensory, a lot of neurons and an area of your brain associated with it. Because we have, part of that kind of makes sense, right? We do a lot of facial features, a lot of expressions, a lot of different things that help us read each other. And so we communicate a lot through our face. So that's a lot. And then plus you have huge amounts of just sensory feeling on those areas, right? It's very sensitive, tongue especially. And then your eyes and all that stuff. So huge area there. Again, your hands, because we've taken a lot of the world through our hands, but your arms and your head and your body and everything pretty small. And then your feet, again, we take in a lot of the world through our feet. That's your trachea, your windpipe, all that stuff down there. Genitalia has a pretty large section. So again, that's your sensory organs. So just if you were to, they do have little, if you want to put a picture of it, people have made models of how it would look if we had all these dedicated areas mapped out proportionally with our size. So this is, figures with giant heads and big hands and feet and everything, and little bodies. All right, functional regions of the cerebral cortex. Okay. So your primary motor area is here in your precentral cortex, or precentral gyrus, I should say, in your frontal lobe. Primary motor, primary somesthetic area is in the postcentral gyrus. There's your taste right there. So if you don't like broccoli, or if you do, blame that little guy. And then your association area, so motor association versus like the motor itself, and then the association of it, and then the frontal association area, like we were talking about, your judgment and all that kind of thing. Your visual area back here, and the visual association. So this is where your visual stimuli come in from your brain, from your optic nerves, and then this is kind of how they associate, how you put it all together. And yeah. Okay, so special senses, so that's your smell, vision, hearing, balance. And those go to specific regions of the brain. So taste is that lower end of that postcentral gyrus that we just saw in that picture. Whereas smell is in your medial temporal lobe and your inferior frontal lobe. So, we talked about the olfactory bulbs right there, right on the bottom of the frontal lobe, but it also goes out to your medial temporal lobe. And then the visual, like we've said several times, the occipital lobe, and the hearing is the superior temporal lobe. So I guess that makes sense, right? Your ears are close to your temporal lobe, so if that helps you remember it, so be it. And their equilibrium is mainly the cerebellum, but then some areas of your cerebral cortex via the thalamus also affect your balance centers. So again, cerebellum is the primary one, but there are some other areas around. All right, your sensory association areas. So this is how we interpret sensory information. So you have your motor area and then your motor association area. So your motor area gets all the signals in, your association area processes it and interprets it. Same thing with your sensory area. There's the one that gets it all in, and then the association is what puts it all together, interprets it. Same thing on the somesthetic association area. So somesthetic, as we talk about that, I mean your position of your limbs, so where you are in space, and your location of your touch or pain, so, and shape, weight, of texture of an object. So if you If you hold an object in your hand with your eyes closed, it's a common object. A lot of times you'll be able to identify it without even, looking at it. So that's one test we do on a neurological exam. We'll have somebody close their eyes and hold their hands out. I'll put like a key in their hand and then have them close their hand and tell me what it's in there. And they should be able to tell me that's a key. If they can't tell me it's a key, well, there's a chance they've never felt a key before, but probably everybody here has. So, they should be able to identify that. So it could be a problem with their somatostatic association. They can feel that something's in there, so the sensory is getting through there, but the association, the processing, the integration of what's happening, what it is, they're not able to do that. Your visual association area, again, identifying the things. So your visual area in your occipital lobe gets all the information that you're looking at right now, but without that association area, you couldn't tell what it was. So I could look and I could just see, shapes and colors and everything else, and it would just be overwhelming. I wouldn't be able to tell what I'm looking at. But my association area says that's a computer monitor over there, and this is a desk. These are students who are keeping their eyes open. Faces are recognized in the temporal lobes. That's a little bit different area. So that's where we talked briefly about it before. People who can't recognize faces, that's a temporal lobe issue. And then the auditory association, again, hearing on the temporal lobe on the side there. So that's how you can remember the name of a piece of music. You can listen to the radio, you turn it on halfway through the song, and you still know the name of the song. You can identify it even without having heard their DJ introduce it, right? Or if somebody who you're familiar with calls you on the phone, a lot of times you know who it is before, even without caller ID, right? That's cheating. But even before that,
Before caller ID.
before caller ID, no such time existed.
Didn't know who was on the other end.
Didn't know who was, yeah. Okay, so then the motor control, the intention to contract a muscle begins in the motor association or the premotor area of the frontal lobe. The precentral gyrus is your primary motor area. So that's there, frontal lobe again, precentral gyrus, frontal lobe, primary motor area is that precentral gyrus. And that processes the order from your motor association areas. You got your motor association areas up here. They send the signal to say, hey, we're going to move the finger. And it passes through this precentral gyrus, and it goes to the spinal cord from there. And your pyramidal cells are your upper motor neurons in your brain. So your upper motor neurons, the pyramidal cells, and they supply the muscles of the contralateral side. So what's contralateral mean? The opposite side, right? So if it happens on your left side of your brain, they're going to supply the muscles on your right side and vice versa. Due to decussation, what's decussation? It's crossing over. Good. So if we did a homunculus, that little person thing there, regarding your motors, your motor neurons, that would be a little bit different looking, but they would have we'll get to, there we go. So that's what it would look like if we had your motor neurons all associated. Again, the face is a really big area, right? Because you have a lot of facial muscles. We communicate that way. We speak. We moving your eyes, all of it. Tongue. Your tongue's a large muscle. Important for assessing the world and what's good and what's not. Again, your hands and your feet. And everything else sort of pretty small. Alrighty. Questions on these things? Nope. Okay, so input, output to cerebellum. So you got that cerebellum there, then stuff goes in, stuff comes out. So this is your smooth muscle contractions, maintains muscle tone, smooths. So like it makes everything a little bit more, you guys talked a lot about muscle contractions, right? So it's actin and myosin fibers and everything. This helps it not be that jerky motion, kind of makes everything a little bit smoother, okay, more coordinated. Maintains your muscle tone and your posture. So you're able to, balance. If I have you close your eyes and put one foot in front of the other and stick your hands out in front of you, then you should be able to stand there for a little while without falling over. And coordinates the different movements, joints, and it aids in learning your motor skills. So when you have muscle memory, we talk about how I remember how to do something without really thinking about it, then that's kind of where a lot of this stems from. It coordinates your eye movements so they move together, as well as that balance center, that equilibrium. Language. So language, which hemisphere of the brain does the language come from? Which side? Left or right? Got a 50-50 shot.
Left.
Left. So language left. LL, language left, right? Language on your left side of your brain. So it includes reading, writing, speaking, understanding words. There's a couple different areas we'll talk about. So I know that's a W, but Wernicke's is how you say it, or Vernix. area, and that's recognition of spoken and written language and creates a plan of speech. Yeah, it's a gyrus, processes text into form we can speak. And then Broca's area generates motor program for the larynx, tongue, and cheeks. So that's transmit to the primary motor function. There's Broca's area and Wernicke's area. Wernicke's, Broca's. These were two guys who figured out, so there was a time when they assumed that language was kind of all over the brain, but they found out that there were certain people that had difficulty with speaking and they couldn't, well, yeah. So Broca's area, we'll get to aphasia. Let me just go to that next. There we go. Okay, so aphasia is any deficit of language, all right? So that's lesion in the same hemisphere as Wernicke's or Broca's areas. So aphasia, can't speak. So if you're Broca's area, there's a non-fluent aphasia. This is, I'll show you guys a video to hopefully help this make more sense. So they have slow speech. They have difficulty choosing their words. Their entire vocabulary can be 2 to 3 words, but they can generally understand what you're saying to them. So you can say, what color is that chair? And they will want to say black, but they can't. The word will not physically come out. They're only able to say, you know, a couple words. Some of them can say more, but a lot of times they get down. There was a guy, they called him Tan because that was the only word he could say. It was tan. So they would ask him a question, and then he would get very frustrated. And so they would say, you know, what color is a chair? He would say tan. You know, how high is the ceiling? Tan. How high is the ceiling? Tan. And the more you asked him, he would want to say, but he would get super frustrated, and he would just yell. And then finally he would swear. And he was French, so he would curse in French. Because cursing comes from a different area of your brain than language. He couldn't do it consciously. If he wanted to curse, he couldn't do it. But that rage factor in that limbic system was able to trigger a different area of his brain, and he would, you know, scream out, Sacred Heart of God, but say it in French. So, Sacre Coeur de Dieu. And so, yeah. So he would, you know, do that. But he couldn't do it if he wanted to. He could only do it when he was super mad. So that was Broca's aphasia. And there was Broca who studied this guy and figured out that after he died, he did an autopsy of the brain and found that there was a big lesion to that area. So that's why it became Broca's area, and he was one of the first ones to figure out that that language had a specific area of the brain. Wernicke, same thing. He studied people who could speak normal, but it didn't make sense. So they would say words, but the words don't make sense. So they would just throw out a word, and you say, so what'd you do last night? Purple monkey saddle bubble. And they would they don't realize that they're not saying the right words. So you look at them, and they're talking to you, and they think they're telling you exactly what you want to hear, but it's not. It doesn't make any kind of sense at all. But they cannot comprehend written and spoken words, so they're blissfully ignorant. You talk to them, and they're just kind of saying words, and you have a nice conversation, and then it's over. They're very pleasant. But Broca's people will get very frustrated because they want to say things, but they can't, and they understand it. So then anomic aphasia, speech and understanding normal, but text and pictures make no sense. Oh, heaven forfend, I couldn't text on my cell phone. What do I do? So, you know, but they can hear and understand, but they would actually have to have a phone call instead of using their thumbs. I think we might dissolve the society now if we can do that. Anyway, so let me show you a couple videos, hopefully help this make a little more sense. So here is Broca's aphasia. So some of these videos are old because we can't study people like we used to. So this gentleman on the left here, he has Broca's aphasia. So you'll hear this guy asking him questions, and he will struggle to get the words out. So I'm sorry about the quality, but again, it's an old video. So.
What this thing was with your legs last week or a week before? No good. Knees and knees and ankles What'd you do about it? Home. The doctor. And legs. Walking. No good. No good. And you're a fellow who likes to walk. Oh, geez. Oh, boy, oh, boy. It's getting too cold. Yeah. To run your John Deere tractor, isn't it? Up and down, too. What'd the doctor tell you, Jim? Don't know. He doesn't know what's going on. No. Did you feel sick in any other way? No. No, no. Ache. Legs ache. Yeah. Did you feel weak? No, no, no. No. Maybe you had a touch of rheumatism. No, no.
So
I have a question,
yes.
just to understand this a little bit.
Mhm.
So is this total language or is this just verbal language?
Total language. So
Okay,
yeah. Well, I should say caveat that with the depends on the location of the
Okay.
lesion. All right. So vernix is usually total language. Broca's sometimes they can write.
okay, that's what I was wondering, would you be
right.
able to write down what he
Sometimes,
means?
but a lot of times they cannot. So, and they won't even. And some of them can like write a full sentence, but they won't be able to read what they just wrote.
Okay,
So
it's total language, but it affects slightly
it just
different.
and it really
depending
depends
how
on the
it
size of the lesion and
Okay.
kind of where it is. So it's potential for total language, but sometimes they can do different things, and if they don't look at it, sometimes they can write a full sentence. Because again, that's it's using a little bit different area of their brain, but then they go to read what they just wrote and they can't read it.
comprehend it. Okay.
So yeah, so it just depends. So that's Broca's. So you can see he knows the words. He's pretty fluent as far as some of them go. He's got more words than some people. He could say ache, knees, ankles. It took him a long time to get those words out though. And you could see getting a little frustrated with trying to figure out like, he wanted to say more, but he just couldn't. So that's Broca's aphasia. Whereas vernix, this guy has vernix.
Hi Byron, how are you?
I'm happy. Are you pretty? You look good.
What are you doing today?
We stayed with the water over here at the moment, talk with the people for them over there. They're driving for them at the moment. They'll save in the moment. He'll have water first. Yeah. Good luck. Yeah.
So we're on a cruise and we're about to
We
use
will
a
sort it
Q&A.
right here and they'll save their hands right there. Them.
And what were we just doing with the iPad?
Right at the moment, they don't show a darn thing.
With the iPad that we were doing. Right here?
I'd like my change for me and change hands for me. With happy. I would talk with Donna sometimes. We're out with them. Other people are working with them. I'm very happy with them. This girl was fairly good and happy. And I play golf. I hit other trees. We play out with the hands. We save a lot of hands on hold for people, for us, on their hands. Of what you get, but I talk with a lot of hand for hand. Some not. I talk of any more to say it.
All right, thank you very much.
Thank you very much. I appreciate it. And I hope the world lasts you.
Thank you, it's been a pleasure. Bye-bye.
Have a good day.
So that's fluent aphasia, right? He was able to say words. They didn't make any sense. And he's, not answering her questions. He's not, with it. Now at the end there, he has some memory of what he's supposed to say. Have a good day. He's got
Like a
that.
repetitive.
It's that repetitive that's
yeah.
in there, but it's, so it's stored in a different area than his stroke affected. But he was not, so that vernix, that fluent aphasia, he's not able to say, anything that has really any meaning to it. So.
Is that similar to how the guy with Broca's like, oh boy, gee, or whatever?
Yeah, exactly. So it's same kind of thing. And the guy who could curse, it's a different area. So it's stored in a different memory center too. So and it's brought about in because of a particular trigger. So then, with the guy who could swear, it was his rage that would trigger that area, and he'd be able to curse. For him and these guys, it was those sort of things that are so ingrained in them, they're able to, oh yeah, oh boy, gee, yeah, that sort of thing. So
I have a question, and again, this might be going too far into it, but
that's okay.
like physical movement, like we use a lot of visual clues with our languages.
Sure.
And so, like, I saw him point off to the side, and like he seemed to have very, I would say, very normal facial. Like when you're talking with someone and he bobs his head and his eyebrows go up and he like smiles a little when he says something, maybe. So would they still have normal? Could they still, like, if you ask them a yes or no question, nod their head yes or no, or is it because they don't understand the language of the question, they wouldn't understand?
So Broca's could nod their hand yes or no, because they can comprehend language. But Vernix, if they do, it's not because they really understand the question. It's kind of coincidental. So he has that motor memory of like he's looking and pointing at something.
Yeah.
Who knows what he's really talking about? I mean, they're on a cruise, so there's water there. So maybe that water word is in there enough, but it's not comprehensible. The
That's
speech
part of
that's
that
coming out.
fluidness.
So,
It
exactly.
still looks and acts normal, but it doesn't make sense.
So that's that fluent aphasia.
Okay.
And as non-fluent aphasia, it doesn't look normal. It's stuttered. It's broken. It's struggling. But the words, when they get out, a lot of times can make sense if they're higher functioning like that guy was. The tan guy, all he could say was tan, 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 tan.
Yeah.
So it just depends on how big of a lesion on the brain. Yeah. Okay. All right, so here we go with lateralization. Okay, we've been talking about left and right brain. So here you go on your left hemisphere. These are your olfaction. Both sides have left and right because that's your right nostril on the left side and your left nostril on the right side. And then your verbal memory is up here. Speech. Again, there's Vernix and Broca's. The right hand motor control. Feeling your shapes with the right hand. Hearing sounds out of the right ear, but again, this is all the left side. Rational symbolic thought, your superior language comprehension, and your right visual field. Whereas your left side, or your right side, sorry, is all your left side of your body things. So your left motor hand control, you're feeling shapes with your left hand. But here we come in different. So this side is, rational thought, but this is hearing non-vocal sounds. This is intuitive, non-verbal thought. This is musical ability. And then recognizing faces and spatial relationships. So this is why some people with damage on one side of their brain, on their right hemisphere, aren't able to recognize those faces, those spatial relationships. They can't interpret the meaning of what you're saying based on your facial expressions. They may be able to comprehend language. They can talk to you just fine, but they can't get any visual cues from you. So left hemisphere is a categorical hemisphere, so specialized spoken, written language, sequential reasoning, math and science, analyze data in a linear way. It's a terrible gambler, though, by the way. So they had, when they first were figuring this thing out, they had some folks with really bad seizures, either trauma-based or sometimes epilepsy, and they figured that if they cut the corpus callosum, that they could fix the seizures, which they did. So they had guys with really bad seizures. They cut the corpus callosum, so now the brain hemispheres couldn't talk to each other. So if a seizure activity started, it wouldn't transmit, it wouldn't go to the body, it wouldn't occur. So they went from like having multiple seizures a day to just a couple a year. So in that respect, it was really beneficial. However, they didn't know at the time, they thought, oh, the left brain is the better brain. The right brain is the dumb cousin because it doesn't do anything, right? The left brain's got speech, it's got math, it's got all this stuff. They didn't realize how important the right brain was. So then they found out that, and the fact that, they knew that lateralization occurred, so where your things that you see on the left side are actually hitting the right side of the brain and vice versa. So they would show pictures of things that on each side that they could only process with that hemisphere. So if they showed them a word of hot on one side and dog on the other, they said hot dog, and they would say, draw a picture of what you saw. Most people, they can see both hot dog, and they would draw a picture of a hot dog, maybe put some mustard on it, whatever. These folks would draw a picture of like the sun being really hot and a picture of a dog. They couldn't like connect the two words together. The same thing with any kind of compound word that you can think of. So we have compound words, you put them together, they make a new word, right? But people who had split brains couldn't comprehend those things, especially if the words were put out on the side. They did it. I say there, it's the left brain's a bad gambler because they did an experiment where if you have a jar of marbles, so there are 100 marbles in there, and 80 of them are blue and 20 of them are red. If you couldn't see the colors and they like would close their eyes and they would say, okay, pick a color, blue or red, and they told the people 80% of these marbles are blue, 20% are red, choose a color. And so the jar was blackened out or whatever, you couldn't see what color you were going to get. So people would 80% of the time, that people who were either left-brained or that when they were testing the left brain, or people who had the bilateral, that had the connecting hemispheres, 80% of the time they would just choose the blue or whatever one I said, the one that was more common. So, but they would like flip it. So if you knew 80% were blue and 20% were red, and 80% of the time you would choose a blue marble and 20% you would choose a red marble. That's a terrible strategy because you're going to get it wrong. So those people are only right about 68% of the time at the best. The people who had the split brain, when they would test just their right brain, they would guess blue every single time because they knew they're going to be right 80% of the time. So, if you're gambling like that, and that's typically like a normal brain person will typically choose 80 out of the 100. They'll say blue and the other 20 because they're trying to guess which one it is instead of being, letting it go, letting that rational side go and just realizing, oh, if I pick blue every time, I'm going to be right 80% of the time. So, yeah. So the left brain's a bad gambler. The right brain's better at that. Perceives information more holistically. Again, the big picture and the perception of spatial relationships, pattern comparison. So all those kind of things. That's why, again, they were able to just say, oh, well, I'm going to be right 80% of the time if I just choose blue every time. So if a kid damages one hemisphere, the other side can take over its function, but adults who really can't. Lateralization increases as we get older. And next is neurocranial nerves. All right. So, and that was the other thing. So we shouldn't think of each side acting independently of each other, though, because again, when they cut them, it really didn't work out very well. Each side kind of plays together to improve our whole process, improve our whole experience of things and how we process information, how we relate to the world, all that kind of stuff. So the hemispheres don't act independently. Just because I'm talking right now doesn't mean my left side of my brain is the only thing that's firing. The right side is, coming up with creative ways to make connections or whatever it is. Same thing with you guys as you listen. Just because you're comprehending language right now, the right side of your brain is making associations, recognizing pictures, that kind of thing. So it's all playing together in a rich tapestry, if you will. Any questions on what we've covered tonight? All right. So we will do this one. All right.
Did you stop the recording?
Oh, yeah.
Probably.
Probably a good idea because you wouldn't be able to.
Me too.